Welcome to another Refrigeration Mentor podcast. I'm your host, Trevor Matthews, and we keep sharing knowledge, and hopefully you're getting some of this and you're taking some of it away and you're going to utilize it in the field, in your daily life. We love that. We're always bringing the top experts from around the world. And this week we got a deep technical session with a friend of mine, Dean Steliga from Bitzer, Canada. He's been inspection doctor for over 20 years on compressors. And this is a game changer. When you understand how to tear a compressor apart, inspect it, you're going to find a root cause of that failure almost every time. And you got to know what to look for. And this is what we're going to be diving into this podcast, because it is a game changer when you know what to look for. Dean, welcome to the Refrigeration Mentor podcast. How you doing?
Good morning, Trevor. Doing very well, thank you. Thanks for having me on, and thanks for everybody for listening.
Well, no, I was super excited when we talked back in March and you're like, yeah, I'd love to come on and have a conversation with you, because you've been doing this for 20 years. You've been seeing the same mistakes happening over and over again. Even though all the training you guys do and all the, knowledge that you share, we still need to continue to put this out, talking about floodback, talking about overheat, talking about slugging, which we're going to talk about today, and the things that you've seen over the years. But why don't you give a little bit of history about yourself in the refrigeration industry?
Well, in the industry, I've actually been in the business since 1985. I started out designing equipment for manufacturers, dehumidifiers and ground source heat pumps, and I moved into refrigeration with Bitzer in 1998.
Awesome.
So I've been here for a while, and
cool.
I've been involved in the forensic analysis and failure analysis of the compressors since for about 20 years now.
Wow. Yeah. So you've seen it all. This amount of time, you've seen it all the different types of failures, all the different types of excuses you heard out there from people, and you've seen it, because I know I've been a part of that as well, and learning. And that's how I got good, is by opening up thousands of compressors, looking inside and figuring out. And not all technicians have the opportunity to do that on a daily basis.
No, that's right.
Every time you get the opportunity, you got to take it. That's what I tell them. So if the compressors failed, you might not be able to do it at that point. Maybe you have to get that process up and running right away. You get the new compressor in, and that afternoon you pull it apart, or that evening at the wholesaler or at your shop, whatever but you got to pull it apart. What are your thoughts about, over the last 20 years, technicians inspecting compressor? Are you seeing more or less or the same over the last 20 years of looking and inspecting from the field side of it?
I would say that we're seeing a lot more recently, very recently, say within the last 4 or 5 years. We're seeing more guys jumping in and opening the compressors up and having a look at them. We seem to find more of that after a training session. So some of our people will go out and they'll do these great training sessions out in the field at the wholesaler or at the customer themselves. And after these trainings, all of a sudden now we've got guys looking at them. And what I like to see when I get a compressor back and we're going to examine it, and you'll see on our report sometimes an observation that the heads have been opened up, or the valve plates have been changed or something. I love to see that. That means the guys are actually taking the time to go and try and repair something before they just send the compressor back or pull it out. And let's face it, these compressors are not small dollar items or small motor. This is a big chunk of change for the customer, the contractor, for everybody involved. So if you're opening it up and you're looking at it, you're trying to determine what the cause is, you think you've got something easy to fix, you're repairing it, we love to see that.
Yeah, and that's exactly right. And this, I've talked to manufacturers from all around the world, and this is what they want, because you can't learn if you do not look inside. There are different rules for warranty and stuff from the manufacturer who put the compressor in as well, because there's different things. As a compressor manufacturer, you sell that to different manufacturers. So you got to follow the policies of the manufacturer of the actual equipment. But you as the compressor manufacturer, you love to see that, because hopefully they learn something from that autopsy.
Correct. It would be a little bit more helpful if they would tell us that when they send us in the request forms to do the return and to send the compressor back. Don't be afraid to put down what you think you found on that compressor. Nobody's judging here. We love to see it. We love to try and get an idea. It helps us kind of look into the compressor and helps us with the overall analysis once we've done all our observations.
Yeah, because the thing is, you get a compressor back, you don't even know what refrigerant it is, the application it is, and any information will be great. Because I remember when I worked at the compressor manufacturer, it would come a burnout. What does that, burnout? What's a burnout really mean to you? It's actually an electrical failure caused by this, this, and this, and that usually comes back to a mechanical failure, which we're going to dive in today.
Right.
What are some of the things that you believe that will really help a technician or motivate them to inspect it a little bit more? Do you believe it is the training that you guys are providing when you go out there? Is it maybe a little bit more confidence in them pulling it apart? What are one or two tips that you've seen over the years that you help technician get to the point where they want to open that compressor up?
Well, absolutely. Education, training, get as much as you can on the compressor, not just one brand or another brand. Get as much as you can on every compressor you can get your hands on. Open them up. Don't be afraid to open them. I don't think there's a manufacturer anywhere that's going to give you a hard time about opening up the compressor and trying to solve an issue.
Yeah.
Just don't be afraid.
Yeah, I totally agree, because like you said, these are high ticket items. And when a compressor is in the middle of a roof of a big warehouse and you need a 300-ton crane to pick that compressor up, put it on the roof, then you got 4 or 5 guys rolling it across the roof, and then you get it to where it is, and then you find out it's the contactor that's the issue and not the compressor.
Right.
And that happens out there. Stuff like that has happened to me in the past. So doing these inspections can save your back, save your customer's wallet, and just bring more value to everyone. Value to the manufacturer, value to the end user, value to your business that you're working for yourself.
Well, absolutely right. Anytime that you can provide confidence to your customer about your skill set, you are going to be the man. Let's face it, and not only for them, you're going to be the man for anybody they talk to in their industry that has similar equipment.
Yeah,
so
100%.
This is just 100% beneficial to everybody.
I love it. Okay, so let's just dive into it. Let's dive into some technical points to really find out. We know, and we've talked about this on the podcast many, many times, there's like 5 or 6 main mechanical failures, and then like 5 or 6 different types of electrical failures. But let's dive into a few of the mechanical failures. What are the main mechanical failures that we could see out there, or a technician could see in the field?
Probably the biggest mechanical failure is lack of lubrication. Something has happened to the oil.
Yeah.
And what causes lack of lubrication? It's liquid slugging, liquid flood back. Anytime the refrigerant is mixing with the oil, guys don't have enough heat in the oil to begin with. This is the reason we have crankcase heaters in them. If minimum oil temperature should be like about 95 degrees Fahrenheit. If you're below that, you got refrigerant in the oil. You're losing lubricity of your oil. It's affecting the viscosity of your oil. This is going to attack your bearings. This is going to attack your rings. It's going to attack everything.
Yeah.
Some of the things that we look for when we're opening up a compressor or something like that is you might see, we'll check the cross hatching. When we get a valve plate off, we'll check to see if the cross hatching is still there. Cross hatching is not there. It's perfectly smooth. This is going to affect the film of oil that keeps the pistons and keeps everything rolling. It's going to cause wear. So that's a good sign, that something's happening with refrigerant in oil or high temperatures even. So it's very complicated because you need to look at all of these things. Too many times, like you said yourself, you see an electrical failure diagnosis, the motor's grounded. I see this all the time, motor's grounded. We pull the heads off and there's no pistons in the cylinders. They're sitting in the bottom of the compressor.
Exactly. So how's that really an electrical failure? The electrical failure did happen, yes. But if the pistons are in the bottom, that motor was still running.
This is why you have to have a look at the compressors, why you have to open it up. Your electrical failure might actually be a mechanical failure, something that you can prevent when you replace it.
Yeah. I totally agree with that. Let's talk about, that's one of the major issues, lack of lubrication. And you just said there's like 4 or 5 different ways you can lose that lubrication. And this is something as a detective, as the technician out there, you got to figure out. Let's talk about, before we dive into that, the process of doing an inspection. So what is your process? Because I know what you do in your lab is different than what a technician needs to do in the field. You know, we just need them to look at a few different things, where you're doing a full blown analysis. You're looking and inspecting everything. But in the field, technicians don't really need to do that to get to the point. Why don't we talk about what you do in your lab on an inspection and what a technician in the field should do before we get into these failures?
Well, the first thing that we do when we start any inspection is we give it an overall look on the outside. We're looking for discoloration. You know, is one head darker than the others? That's going to give us a hint of what might have caused the failure. The first thing we will open is the terminal box. You're going to look at the terminals. Are they dark? Are they overheated? Is there a leak at the terminals? Well, overheating terminals can cause refrigerant leaks. There's something to look for if you're having low refrigerant charge. You know, are they leaking around the terminals? Have I overheated them? What's causing that overheat? So we're looking at that first. We check for the color. If we see a discolored head, that's the first head we're going to open up. And we're going to look at the valve plate. And we're looking to see if there's valves are deformed or if there's any color on the valves, right? So if you see rainbow color or a copper color or something, you've got high temperatures, high internal temperatures. This is giving us an idea of where to look for problems.
Yeah. And that's so important, you know, getting into doing that. And the first one's a visual one. Right off the bat, that one's a pretty easy one, visual, if you see it really hot. And these are tests with the new tools that we have out there today, like the flare and the thermal imaging gun. You can see this stuff, because I know I've read so many Bitzer documents, and they'd say if your cylinder temperature is this and your one right beside it is like 30 degrees Celsius difference or even Fahrenheit difference, there's an issue. They should be pretty close together. But if you get this big difference, and could be even while it's running, so that visual inspection is probably the key to start with.
Absolutely. If the compressor is running and you're having issues, you know, obviously you're going to check your suction line superheat. But something the guys very rarely check is the discharge line superheat. This is so important because it is reflective of the refrigerant you're using as well. There are differences there. So, you know, a minimum superheat of 20 degrees Celsius for most refrigerants and 30 degrees Celsius if you're talking 410A, 407, R22. CO2 is even higher than that. So you need to have those minimum discharge temperatures. If you don't have it, if you're below that minimum discharge superheat, you're going to be looking at flood back to the compressor. You're looking at poor oil distribution, oil breakdown. These are things that if your compressor's running, don't forget to check that.
Yeah. And I think that's the thing that when I worked at Copeland, I always trained a discharge temperature check, which is key. But when I started learning more about Bitzer and talking with Phil and the team there, they were like, you need to check discharge superheat. Do you want to explain how technicians can check the discharge superheat?
Well, the discharge superheat is going to be, you need to actually measure the discharge line. We like to say, some people say 6 inches. We like to say within 4 inches of the valve. You want to measure the temperature of that line, and then you need to take the condensing pressure of your system, find out what your saturated condensing temperature is, and your discharge superheat is the difference between the two.
Yeah.
So you're looking for 20 degrees Kelvin, which is Celsius, the differential, or 36 Rankine for most refrigerants, 36 Fahrenheit for most refrigerants. R410A, 407C, 22, you need to be getting 30 degrees Kelvin or 54 Rankine. Okay, if you're below those, you need to start checking your suction superheat, your suction flood back issues. You need to check that.
And these are quick checks because these are main checks on any system.
Absolutely.
Just like you do. Suction temperature, suction pressure, discharge temperature, discharge pressure, sump temperature, if you can get it, you know, the oil temperature.
Absolutely. For our compressors, you would take that right at the oil drain plug or the, right at at the bottom of the compressor, at the bottom of the sump. You want to take a temperature right there. You need a minimum of 95 degrees, but you need to keep it under, right? You need to keep it under, what's our saying on there? I think 175.
Yeah. Yeah. So that's super important, because if not, you could have, like you said earlier, refrigerant in that oil.
Absolutely.
If you got refrigerant in that oil, you're going to start losing that lubrication. It's not going to kill your compressor right away, but this is where the damage starts. And this is what I try to teach technician. It may not, fail that compressor that day, but if this happens over a period of time, it's going to rapidly decrease the efficiency of that compressor, which will lead to a quicker failure, because your compressor should last 10, 15, 20 years if they're serviced, maintained, and installed correctly.
Oh, absolutely. Absolutely. Some of the condensing units that I designed in 1998 with the Bitzer compressors, they're still running.
Yeah.
So, good maintenance program, you should be checking these things, and always check the oil heat. If you don't have adequate oil heat, do you have a crankcase heater installed? I've seen them come back where it was evident that there was no heater ever installed in the compressor, and the compressor failed because of liquid in the cylinders and bearing failure. We knew what happened. If the crankcase heater is installed, is it working? Right? Is it working properly? Is it working on the off time of the compressor? So are your controls working with that?
Yeah.
So this is all super important stuff to do before the failure happens. This should be part of your maintenance program, actually, going in and just making sure all of that stuff is where it's supposed to be. And you can find the information that you need for that from any of the compressor manufacturers, Copeland, Bitzer, Carlisle. They all publish this information, so it's readily available.
Yeah, exactly. And it's easy to find today. But once again, it's like we talked about earlier, it's about the repetition. You got to do it and do it and do it over and over again. Right. One of the big things is that I work with a lot of supermarket technicians and contractors from around the world, and they rely a lot on that PLC, that controller, the temperature. So, okay, well, the suction pressure is this, the discharge pressure is this is the SSTs. But that's for all 6 compressors running or all 8 compressors running. Do you want to talk about, when you're working on a multiple compressor application, what the process is? Instead of just using the controller information, because that's where a lot of guys get tricked up. Because if I have 10 compressors and only one cylinder is gone, can you tell that from that header suction pressures?
No. You need to examine the compressors. You need to go and look at them, and you need to look at, check this stuff individually. Go through the rack, one compressor at a time. Look at your cylinder head temperatures. Is one cylinder on one compressor hotter than the others by a lot? That would be my suspect right there. That's where I would go. You got to break it down. Don't rely on what the controller is telling you. Are the sensors still accurate on the controller?
Yeah.
Is it reading the proper things? You need to question these things, and always inspect them one compressor at a time. Yeah. Check the temperatures one compressor at a time, because you can have 6 compressors all running, and the system is causing an issue where one compressor is seeing a lot of oil come back to it, maybe even through the suction line, and the others are not. And it's causing the problem on that compressor. One compressor is vibrating a lot more than another. These should be fairly smooth operating machines. If one of the compressors on the rack is shaking, I would be right away on that and having a look at it.
Yeah, I totally agree. And this is what I tell the technician is not, you're just not measuring all of them all at once. You gotta do it individually. It takes time to do this stuff individually, each one, and then you're going to find a problem a lot faster. Does it take longer? Yes. But this is a part of our job. And when we do it right the first time, we don't have to come back and do it a second time.
Absolutely. And if you're talking about a rack that has 6 compressors and each compressor is worth thousands of dollars, it's worth your time. Yeah. And your customer is going to understand that it's worth your time.
Yeah. Another big one that I talk about, and a lot of people, when we get into the supermarket, they have trouble with oil management, oil systems. Do you want to talk a little bit about the different oil management systems you guys provide for your customers?
Well, that's getting a little bit out of the forensic analysis, but oil management systems, we rely on aftermarket products, obviously, but mostly what we're looking for is something that can provide us a steady level of oil return back to your compressor. So a lot of times, these can cause some really interesting failures because the valve sticks, the oil's not coming back to the compressor, and you've got a lack of lubrication system or a situation, right? Yeah. So, oil management's super critical. Always check your oil management, part of your maintenance program. Yeah, absolutely.
And sorry, I didn't ask that question correctly. The two different types of way you guys lubricate your compressor. So that's what I meant by the question. So that was my bad.
Absolutely. Well, depending on the compressor that we're talking about, if we're talking reciprocating compressors, we lubricate two different ways. We have the dynamic disc, which is a splasher type plate that picks oil up from the crankcase and drops it into a receiver cup at the front of the compressor, which is drawn down the crankshaft through passages in the crankshaft out to the bearings and out to the rest of the system. For the smaller horsepower compressors, the 10 and 15 horsepower maximum sort of compressors in regular refrigerants, or any of our CO2s that are 4-cylinder or smaller. This works fantastic. It's a great system. What we do on the bigger compressors, bigger recips, they have a gear pump in the front. So it picks up the oil from the crankcase through a dip tube and pumps it out into the compressor through the crankcase, through the crankshaft.
Yeah. And so on there's two different ports. You got a positive and a negative. What should that be for when a technician is going to check that? Because we said earlier, lubrication is one of the biggest causes of failure. What should that look like when
you like to see 45 pounds across those two ports? You really do want to see that.
Yeah.
And if you see 45 psi,
if you don't see that, there could be many things that are happening. Like we'll get into, flood back could be an issue.
Sure.
Low oil could be that oil management control that we talked about a little bit earlier. It could be one of those things. But this is one maintenance check that you have to do on every pump. You don't just check one and all the pumps are good on all of them. You got to check each one individually.
Correct. Absolutely.
I love that. Why don't we dive into a little bit of flood back and we'll talk about what flood back is and what you would see when you are opening or looking inside a compressor for telltale signs of a flood back situation.
Well, flood back is actually liquid droplets in the suction gas that's coming back into the compressor. So it might not provide a liquid slugging smash like you would see if you have a cylinder full of liquid that's trying to compress itself. What you will see, though, is the liquid tends to dissolve in the oil. They just love to get together, refrigerant and oil. They adore each other.
Yeah.
And when it does, it reduces the viscosity, it reduces the lubricity of the oil. So what you're seeing with liquid flood back is wear. And we see that in rear bearings, main bearings. You'll see that, as I said, in cross hatching. You can get a good idea if you're getting liquid flood back. If the system's running again, check that discharge superheat. If the discharge superheat is too low, you probably got liquid flood back coming in. You're going to have to get that suction superheat higher somehow.
Yeah.
So we see that in wear. That's what we're really looking at. And see if I have something on that.
Yeah, and for those that are listening right now, we'll have the video of all the slides and stuff up on the YouTube channel just to check that out, because it's important to visually see it. But once again, you got to hear this. Listen to this 3 or 4 times. Take notes while we're talking about this, because this is going to help you out in the field.
Yes, sir. So some of the things you're going to see with the wearers, we talked about this, the cross hatching. This is something you can check in the field when you take the head off and you're looking at the valve plates and that sort of thing. If you lift the valve plate, you can check those cylinders and see if the cross hatching's still intact. If it's not, you've got a situation where you have high oil carryover. You've got lack of lubricity. You may have liquid refrigerant in the oil. What temperature is the oil in the crankcase?
Yeah, that's exactly right. And this could be caused by a faulty TX valve or electronic valve. It could be a frozen coil in your evaporator, all the fans out for some reason. Something may be electrical that could be causing these mechanical issues. And this is why you got to look inside, because if it's super shiny in there, that's not good.
No, that's right. That's right.
And if anyone worked on cars before, it's a similar thing in the engine. They have that cross hatching inside there. This is for the lubrication to keep that. And like Dean said, if that's wore and it's shiny, and as that compression pushes up, but it's all wore there, all that discharge gas could be potentially starting to go inside the sump of that compressor. I want to talk a little bit about that. What this flood back situation where we think about, okay, TXV malfunction, or you had a frozen up coil. Now we flood back. Now we wear that cylinder a bit, and now it's super shiny. And what would happen next? So we're pumping that discharge going into the crank. What is the signs at that point for a technician?
So now you're not, you have no oil. You have no oil creating that lubrication film for the piston. You could be seeing some blow by. You could be seeing some discharge gas, getting some hot gas getting down into the crankcase. That will start bringing temperatures up again. So you could see that oil sump getting higher and higher in temperature. And as you get higher and higher in temperature, again, what happens to the oil? You lose viscosity. So there's two situations with the oil where you're losing lubricity. Yeah. Too much refrigerant in the oil, which is low temperatures, or too high temperatures causing viscosity breakdown. And you're getting more blow by coming by, which is causing more wear. And as these things are turning at, 1800 RPM, so those pistons are going up and down, 1,800 times a minute, you're going to wear out some bearings, and you're going to wear out some cylinders and rings, and cause the compressor to stop pumping gas or even seize.
Yeah. And we talked about that. Dean already talked about that check. You got to check that oil sump temperature. If it gets over that 175 Fahrenheit, that's an issue. And that could be a sign of potentially, and I always talk about in sequences, because it just doesn't happen. We had the fans go out, we froze up the coil, we had liquid returning as droplets, we wore the cylinders. Now all of a sudden the discharge goes into the oil, increases the temperature of the oil, which maybe led to a seized compressor. But before that, if it's still running, we're 200 degrees Fahrenheit oil. There's an issue. What is it?
Absolutely. So anytime you can check those things while you're running, you're gonna help prevent that compressor from failing.
Yeah. What's a good way to check without the tools? We always need to put the gauges on and the temperature probes and the gauges. But what would be a good check? Because I've always told guys, if you see in the sight glass, it's full of foam, and all of a sudden the oil starts to drop off, potentially that could be flood back. Do you want to talk a little bit about a few things that could cause foaming in the oil?
Well, absolutely. Foaming in the oil would be like, as you mentioned, you've got liquid refrigerant coming back in. It could cause foaming in the oil. There are other reasons for foaming in the oil as well. It may not be a serious issue, but it should be a trigger to have you go and measure all these other temperatures and make sure that, if everything's in the manufacturer's specification and you've still got foaming in the oil, then we'll have to look at maybe something else a little bit different. But generally speaking, foaming is a function of liquid flood back. Yes, where you got liquid in the refrigerant.
Yeah, and this is something you go up and you look in all the sight glasses. If you don't have any foaming, okay, you still want to check your suction superheat, your discharge superheat, your pump pressure, your oil sump temperature. These are checked, and your amps and your volts all the time, because all that interplays. Because you take this information and you go back to the Bitzer software or the app, and then you plug that in for that specific compressor, and it will tell you if you're running efficiently or not.
Absolutely. So what is the result of this lack of lubricity? In fact, when this oil loses its lubricity, loses its viscosity, what can happen? You might end up with a little bit of extra oil carryover, which means your oil is now leaving the compressor in excessive amounts into the system. There's no more oil in the crankcase. So what a lot of guys may want to do is pump a little more oil in there and see what's going on. Now you're causing oil slugging in the coils, in the condenser, in the evaporator, all this oil sitting in there, reducing your system's efficiency, creating capacity issues, and maybe causing further problems with overheat or out of spec systems. So again, check these temperatures.
Yeah, and I totally agree with that. I have a lot of people that send me pictures with cylinders full of oil. They're like, Trevor, I just took the head off, but my cylinder is full of oil. Both cylinders are full of oil. Do you want to talk about some different ways that the cylinder, the top of the cylinder, could be full of oil between the valve plate and the piston?
Well, sure. This is again, this is another lubricity problem. Your oil has lost its viscosity. It becomes like water. It can get through it can go everywhere in the compressor. And most particularly, it ends up carrying forward into the cylinders and into the valve plates and the discharge galleries. So you can get a lot of oil built up in a short period of time because of this. It can also cause a liquid slug. And you'll notice this right away when you open up the valve plate and you find, well, a couple of valves are missing. Or,
Yeah, it's
or
like
there's little chunks of metal all in the discharge gallery. Or more commonly, what we see actually is you'll see discharge valves actually bent, missing, broken when you've got a slug happen from inside like that, when it's a carryover slug like that. So you'll see that sort of thing. If you're looking at bent suction valves, that is probably liquid refrigerant coming back into the compressor, too low superheat.
Yep. And so that too low, and is it different on different compressors, like pump style versus your dynamic disc or splasher feed style when flood back is happening? So you have a pump or you have the splasher disc when you have flood back happening. Does it look differently? Does it look exactly the same? Depending.
Well, if the thing about having a liquid flood back or refrigerant in the oil in a pump system, of course, is the pump may cavitate a little bit. So you could see a little bit of wear inside these gear pumps, and it's not really common, but you could see that the refrigerant gas will flash out of the oil at the pump. As the pump increases pressure, the gas will actually flash out of the oil before it gets into the compression cycle of the pump. And you'll get a little bit of cavitation, whereas with a splasher system, you won't see that.
Yeah. Okay. Well, that's kind of how we dove into, flood back. Now, what's the difference when you get a flooded start? You know what I mean? Like, what causes a flooded start, and what does that look like when you're doing an inspection?
Flooded start. When you get a flooded start in an inspection, we're going to see blown head gasket. We're going to see broken suction valves, bent suction valves. You're going to see smashed pistons, rubble in the crankcase at the bottom. When you lift the valve plate off, and if you can move the pistons up and down in the cylinders, you're okay. But if you push on one of those pistons and it goes right into the crankcase, yeah, you've got an issue there. And liquid starts, flooded starts is probably one of the worst conditions that I think you can get, because at this point, your cylinders are full of liquid refrigerant that have migrated there, or oil that has actually been pumped up into there. And as the compressor, the gap between the top of a piston and the valve plate is very, very small. That's how we get our efficiency. When you're trying to compress, even small amounts of liquid in that little gap, you can't compress a liquid, so something has to go. And it's always mechanical, and this is where you're going to see the damage to the valve plates and pistons and connecting rods. And yeah,
exactly. So I'd love to talk about the difference, and if there's a difference. So we got a slide of liquid slugging showing deformed valve, blown gaskets, damaged valve plates. But could you tell a difference between flooded start sluggings or flood back sluggings when you're doing an inspection?
It's very hard to do, although a flooded start, generally speaking, might not have the same amount of bearing wear and wear on components underneath at the bottom. Whereas liquid flood back, you will definitely see wear. You'll see wear to the, we use a PTFE coating on the bearings. You'll see that worn right out. You might actually see rubble in the bottom of the compressor, because the connecting rods have bearings in the connecting rods, and as those wear out, sometimes they don't seize, they just shatter into a bunch of little pieces. So you'll see that kind of thing. If you've got a lot of wear, a lot of excessive wear, you're probably looking at flood back. If you've got one cylinder that's smashed a piston or broken the valves and there's not a lot of wear, that cross-hatching's still there, you've probably got a flooded start situation.
Yeah. And so you just got to remember too, the different components in the system. If you have an accumulator in that system, it's going to help protect against the flood back. But does that protect against flooded starts, Dean?
No. This is something that flooded starts. If you get liquid migrating back down to the compressor over a long off cycle or something, then the liquid is migrated to the coolest part of the system, which at that point in time is the one compressor. This is where you're going to have issues with flooded starts.
Yeah, and I totally agree with that. Okay, there's one thing that I've been teaching for years when I've teach on Copeland compressors for 460 compressor. If you have major flood back with their pump system, the very furthest bearing is always going to get wear first because you have oil traveling and it gets less and less oil. I've always taught shake hands with the crankshaft because that main bearing on the pump systems would be the first go. So if there's a lot of up and down play on the crankshaft, that means that stator would drop and scrape. And then you usually get that where guys say it's a burnout, but actually it's a flooded back situation because the main bearings were drop the rotor drag.
Correct.
Cause that electrical failure. Would that be a similar test in your Bitzer compressors?
Absolutely. Okay. We have the rear bearing as well, but you'll see when we see rotor drag, we're going to see that very quickly when we open the back cover. And you open that up, you're going to see right away because the rotor itself has got definitive marks. You've got a black motor because the whole thing burns and it burns very, very quickly. It's not a slow burn. Like you would get with overheating or liquid flood back. But you'll see that sort of situation.
Yeah.
See if I have something on that.
Yeah. The thing is though, we kind of got into how to inspect it. If you're going to take the back cover off, make sure the oil is out. So that would be the end bell. So you got to make sure it's drained. A lot of the times when we're doing it, you're doing an inspection, you just have to safely isolate this compressor, lock it out electrically properly, get all the refrigerant out safely, recover that refrigerant out of there so you can safely work on it. When you loosen the bolts, don't pull them all off. Make sure there's still two in there, and then you crack the head. So if there's any pressure, it doesn't blow on you. But if you're going any deeper than looking at the heads, you want to pull that oil out. Even the pump. I think you could take the oil pump off maybe without having to drain the oil, Dean.
I wouldn't do it. I would drain the oil anyways. Yeah, you kind of want to do that anyways because you want to have a look at the oil itself. And this is something you can actually do in the field quite easily without opening the heads and everything. It's just take a little sample of the oil out of the compressor and take a look and see what's happening. If it's black like tar, you need to get deeper. If it's really clean, well, now you have to look at maybe different things because if it's really, really clean, if you're getting any kind of bearing wear, you're going to see a little bit of coloration in that oil. You'll see it a little grayish. If it's crystal clean and yellow, I'm not talking about the bright, leak detector yellow, but if it's crystal clean and clear, then you probably don't have that much wear in the system.
Yeah.
Again, you're going to do an analysis to see if there's any kind of acid or moisture and everything. And this is something I said on the bullet points is non-condensables are a huge cause of compressor failures. Huge cause. You have oxygen in the system. Somebody's done a test and used the oxygen on their torch, whatever they want to do. It's or nitrogen in the system, and they haven't pulled it out. You got a multiple compressor system feeding your condensers, which could have multiple circuits and multiple control valves and everything. Did you open up all the valves when you pulled the vacuum and this sort of thing? This causes, if you don't do this and you have non-condensables in there, these can cause issues with your oil as well. Like these come back into the oil, they create acid. You can see that in maybe some copper plating in the bearings and things like that, when you get enough heat.
Yeah. I want to just before we dive into these pictures here of lack of lubrication, what are your thoughts on testing oil? Because this is what I'm training heavily for maintenance. and how and why technicians need to be checking oil in their systems consistently, especially the supermarket ones. I'm not talking about the little 1 ton or 2 ton systems, but talking about supermarket racks or larger systems that have multiple compressors on it. And what are your thoughts on the type of oil analysis they should be doing?
Well, from a compressor standpoint, you need to be checking to see if you're, well, if you've got viscosity, it's a little difficult to check. You can test for that actually. If you've got good viscosity, if the oil's clean and clear, really look at the color, look at the oil itself. If it's grayish, looks smoky, you've got a high temperature situation, you got bearing wear situation. If it's black and opaque, don't just change the oil. Now we have to dig in and check the motors, check your motor, check your terminals, see if the motor is still in good shape. You want to open up the heads. You want to check the pistons, make sure they're moving tightly. There's no slop or play between them, which might indicate bearing wear down below. You have to get deeper when you've got black oil. Some guys just drain it and change it.
Yeah.
Should never do that. Should always check for it. Good idea to do an acid test because you don't know what's happened in there. If you've had some kind of an overheating issue, there was a little bit of moisture left in because of, like I say, evacuation or whatever reason, you got a bit of water in there, like water-cooled condenser, had a busted a leak or a pipe broke. You don't know how you're going to get that in there. You want to check for acid because acid will eat the insulation off your motor. It will eat away all your bearings. It'll just do all kinds of damage to the compressor. Yeah. If you've got acid in the oil, now you've got to get deeper into the system.
Yeah.
You can do the cleanouts and, doing cleanouts is great, but make sure you understand why is there acid in this system? There should be only 2 substances in any refrigeration compressor, Trevor: oil and refrigerant.
Yep.
That's it.
Yeah, exactly. And this is why it's not just going by the $50 oil kit or acid test kits. You got to send this out to because if you got a big system with 20, 30, 40 gallons, you got to send this to a lab. It's not that expensive either, maybe a couple $100. But an oil change could be tens of thousands of dollars depending on the size of the system because how expensive oil is. So send it out to a lab and actually get it tested. I tell everyone, if you're on a big system, once a year, that's part of your maintenance. And then it'll tell you, do you need to do an oil change or not?
Yeah.
Right. And then go ahead.
Or if you have an issue.
Yeah.
Exactly.
I love that. I see on here. So lack of lubrication. So those that are listening, you got the rotor drag, you got the worn bearings. You got the worn pistons because that's your journals off your crank. Let's talk about the wrist pins. What are some tests for wrist pins and how you can get damaged wrist pins in a system?
Damaged wrist pins is, again, you get a bit of acid in the system. It's lubrication. Guys, it's oil. Okay. Yeah. Lack of lubrication. Overheating, which is caused by lack of lubrication or high temperatures, high return temperatures. Operate the compressor outside the manufacturer's envelope. We actually test our compressors, guys, so that envelope is actually a proven envelope. Yep. And when you operate outside of that, that's where you get the oil breakdown. So you're going to see copper plating on the wrist pins. You're going to see scoring on the wrist pins. You could see wrist pins wearing an elliptical, they fit into the pistons fairly tightly. And you'll see that opening in the pistons themselves turned into an oval as it wears itself through and your piston gets all sloppy. And this is lack of lubrication, overheating, temperatures again.
And I love that because these are little things that you need to check consistently. So one way that I have always taught, is that you get the piston top dead center, turn a little bit, and you push down. If that just drops, you got wrist pin wear.
Absolutely.
And that compressor, because I know that a lot of people can, back in the day, everybody used to just fix the compressor, change a piston, because that's what they had to do. Yeah. Today, it's not as common, because there's more mistakes that can happen. But if you find that out and you see it's a wrist pin wear, you got to change, you got to replace that compressor.
Absolutely.
And because there's a lot of times if you get once again, it comes back to that process. What really happened? What was the story of the compressor? And this is what I kind of talk about. Well, a slug happened, the discharge valve smashed. So because of that slug, whatever caused that slug, and now you got discharge pressure pushing in on the piston, so the piston's not coming up as far. Now it's starting to wear that wrist pin, and now you get that wrist pin. So just instead of replacing that valve plate, because that's a lot of money just to do the valve plate, do your customer a favor, because if you hear a knock in that compressor, maybe the compressor needs to be replaced and just not the valve plate. Do you want to talk about some compressors that you've seen come back where they could have stayed in the field with a quick, not a quick fix, but a repair instead of a replacement?
Wow. We're talking probably 5% at least of the compressors that we see coming back. You don't even need to repair them. I get 5% of those compressors come back. They're spotless. They're brand new. There's absolutely no issue with these compressors. Something happened in a control or, miswired overload, something outside of that compressor has happened. They've changed the compressor, many thousands of dollars, sent it back to us. And honestly, you could take that compressor, put it right back there. It's going to work fine. 5% of those are no issue at all. There's probably another 10% that come back where it liquid slugged one cylinder and it blew a gasket or it blew the valves on the valve plate. Everything else is fine. We've checked it. The pistons, there's no slop, there's no wear, there's no stiffness in the mechanics. Change the valve plate and you could run it again. Yep. We can't do that here. When we do an analysis, we tear it right down to the very last bolt.
Yeah.
So we've got brand new compressors torn down to the very last bolt sitting in the back in our shop.
Yeah, no. And I love that. And that's how you learn. I tell the technicians at least once, you got to pull it down like that, pull everything apart. You don't have to do, when you're doing it more and more inspection, you don't have to get that deep as the manufacturer does, but just do it once so you can see all the components. And I send so many people to I think it's the Bitzer e-parts store, so they can go in and look at every component inside one of your compressors, because it's so important, because just one of those components could fail in there that cause the issue from a system related issue. A lot of people are like, oh, well, it's the manufacturer's issue. It's the compressor issue, but
yeah, it's a defect.
Yeah, it's a defect.
No, it's not.
There is a small percentage of all manufacturers that have, because you're making millions of compressors,
Absolutely.
But it's
absolutely.
Like 5%, 2%, and we're talking millions of compressors, because you guys do have unbelievable quality control. You're not letting compressors just go out. You're testing them, you're running them, and you're making sure that they're good before they go. If you get it to site and someone's saying it's a DOA, dead on arrival, there's something else going on 98% of the time.
Here's something that I do see a lot. We'll get a claim back. We want to return the compressor. They're requesting the return, and the cause of failure was DOA, and the compressor started on May 1st, 2023, and it ran until October 10th, 2023. So, guys, that's not DOA.
Yeah, exactly. That ran.
It would have been a lot more helpful for us in helping that particular customer and getting back to them with reports, and even sending on-site assistance if they could have told us that, well, we're not really sure why it failed, but it was pulling lock rotor ramps when we got to the site, and it blew breakers. That's more helpful than DOA.
Yeah.
Or motor grounded.
Yeah, that's another one. Motor. Well, what caused it? Once again, it's 80% of the time is that mechanical issue. And what caused that mechanical issue or more? You know what I mean? Well,
right.
It's one of those system related issues. Low superheat, fans gone out, non-condensables into gas. Could be one of many things, but that grounded compressor was grounded for a reason. What's Correct. The story? I keep telling her, because the story. That's what I love about talking with people that inspect it and failure analysis. The story. Doesn't matter the refrigerant, doesn't matter the application. You can really pinpoint what that story is. And if you talk with that technician in the field, you could probably say, look at this, and this. And that's where your problem is. So when you put the next compressor in, we don't get one back in 2 weeks or 6 weeks or 8 weeks or 2 years. or 6 years, because it should still run.
Well, this is the whole point. I mean, you don't want, you're going to have to replace compressors. Yeah, we know that. You don't want to have to replace that second one. So you really need to go in and look and see, try to analyze what's happened. I'll be honest, it's not always possible. Sometimes we get compressors back that are so badly destroyed and so badly burned. It's almost impossible to determine, was this liquid flood back? Was this too high heat? What actually caused this? We try to do our best. But you got to look and say, everything here, this motor burned. Did the motor burn first? Well, if your parts are smashed in the crankcase, no. The motor was still turning because that's how the parts got smashed. Did the motor burn first? Everything's in impeccable shape on the other side of the on the mechanical side of the compressor, but it's covered in soot. Soot everywhere. Well, and right through the whole compressor. That's evidence of a slow burn. That happened over a period of time. Could have been, many seconds or minutes or hours, whatever, but it didn't happen like a fast burn in under 1 second. Yeah. So when you see a lot of soot, you open that valve plate and it's covered in soot and, looks like your old chimney. You've got a slow burn. This is something to do with operating the compressor outside the envelope, too high heats going into the, too high suction superheat. Maybe some valve damage causing discharge gas blowby. So now we're going to go look at those components to see if anything was found there. So
yeah, and it's so important to take your time with this, because I see a lot of technicians kind of rushing. They feel that the stress of having to get to the next job, putting out a fire here, going to the next job. There's a lot of pressure on the technicians today in the field. But I promise you, if you take the time to inspect these compressors that fail and you figure that root cause out, you're going to go so much further in this industry. You're going to be way more valuable for any organization as well as those customers, because you're taking the time. If it takes you an extra hour, and I know it doesn't take an hour to do an inspection to find out if the valves are busted or if a piston's busted, if you can take 15 to 20 minutes to inspect that failed compressor to find the root cause, that's game changer for you and your business and your company.
Absolutely. Absolutely. And if I know time is always an issue for everybody, but anyone that wants to take the time to take that old failed compressor back to the shop and, to do a complete teardown, it's going to take you 3, 4, 5 hours. Okay. You're going to take time to do it. It's well worth the time. And especially if you've got more than one mechanic in there, get everybody involved, try and make an afternoon barbecue or an evening barbecue out of it. Yep. And just go to town and have a look at this thing. It's going to give you so much knowledge as to what's going on in that compressor and what happened in the system. And you kind of have to be a little bit of a Clue CSI kind of geeky guy to get into that. Yeah. But I promise you the knowledge is really impressive. When you get in there, it's kind of fun too sometimes. Yeah.
And the more and more you do it, like when you started out, it took a long time to do an inspection. Now you could take a compressor now, do even filling out your report, and you can crush it. You know what I mean? You can crush it in less than a half an hour. You could probably find a failure. So you do it so many times, you can find a failure maybe within the first 15 minutes. Maybe the first 10, you pull off that first head and you can do it. But it does take time, and it takes that repeat of doing it. So if you're only doing it once in a while, you got to do more of a teardown. But over time, you'll get faster and faster and faster doing these inspections. And the telltale signs, just like the pictures that Dean is showing right now, is that the lack of lubrication. When you see this stuff, you're going to be okay, that rotor drag could have been from this, or this. Okay, now let's check when we get the new compressor in those that operation of that to find out what was the real true cause.
Absolutely. Some of the other things that we see coming in as well when we're inspecting, we're looking at the motors. We want to see what happened. Is there a way for us to determine what happened? Some compressors come in and the mechanical side is fine and the motor's burnt. What's going on in there? We pull the end bell off, and what are we looking at? We're looking to see if there's anything that was abnormal electrically. So a lot of guys, when they replace, a lot of people when they replace contactors, a lot of people when they design systems, they put in a contactor and the contactor isn't sized correctly. and this can cause some major issues. The contacts bounce, they weld on one phase, some kind of thing. It can cause single phasing. It can cause, all kinds of issues, but it always causes a motor burn. So guys need to size the contactors correctly. Don't just, the compressor says my rated load amps on the compressor is 30 amps. I'm putting a 30 amp contactor, 575 volt in there. Nobody looks at the locked rotor amps.
Okay, so this is a good point. So why don't you explain how somebody should go about sizing a contactor? Because this is where you need to get into the Bitzer app and take a look at that specific compressor, because each contactor is going to be different depending on the size of that motor.
Absolutely. Let's have a look at an example. So we're going to take a direct online. That's most applications really are direct online. There are a few part wind starts, so there's some considerations that have to be taken there. But for a direct online compressor, 575 volt. One of this particular model, the MCC, which can be found on the rating plate, divided by 1.4 will give you your rated load amps. If you don't see your RLA on the plate, some of them have it, some of them don't. So this particular compressor, 25.7 amps, and the locked rotor amp on the compressor, right on that rating plate, 140 amps. So when we're sizing the contactor, you want to give yourself 25% safety margin. Bigger contactor is less of a chance of failure. So what we're looking for is something that can handle 25.6 rated load amps and 175 amp locked rotor current. This particular contactor, very common one, when we look at 575 volt, we find that this is a 30 amp contactor, and that in 575 volt, the locked rotor amp rating is 4 times the full load amp rating of the contact. 120 amps.
Wow.
120 amps is not even the no safety factor locked rotor current that you could experience with that compressor. So this contactor shouldn't be in place.
Wow, that is so important. And this is how actual true electrical failures happen. This is not a mechanical failure. This is a true electrical failure. What are a few other telltale signs? Because you got single phasing, like you said, you can have a turn-to-turn short, could be contamination that causes a phase-to-phase short. What are a few of the other electrical issues that you could see?
Let's look at this little guy here. So if we're looking for, if you open up that compressor end bell and you can see a defined pattern. So you've got clear copper, 3 windings, three turns of clear copper, 6 turns of jet black, 3 turns of clear copper, 6 turns of jet black. This is a single phased motor. So this is a motor where one point on the contactor failed, and that clear winding, that new winding, is the winding that did not get power. That's the one where the phase dropped off. The black windings are the other windings that tried to make up for, that motor's got to turn 40 horsepower. It's going to do it on 2 windings. If one's not there, pulls way more current through those windings, burns them up like that.
I love that.
So this is a great, clear example of single phasing. It's not always this obvious.
Yeah. Yeah. What are a few other electrical failures technicians can look for? Because I think those ones are sometimes a bit harder than the mechanical failures, but all of them, it takes experience in looking at them.
How about let's see if we got, what's this one? This one, anybody who's opened up a motor that's fully burned has seen something like this. This is a complete overload. So the compressor was operating outside its rated conditions, outside its envelope, drew way too much current, and every winding burned in the motor. This is assuming, of course, you don't have rubble in the crankcase, which caused this to happen, right?
Yeah, exactly.
Yeah.
And what are a few things that could cause the overload?
If you're operating outside of, you have no motor cooling, no auxiliary, no additional cooling in an area of the operating envelope where you need additional cooling, that can cause an overload. If you could see overloads happen if you have an extended pull down condition where you haven't throttled back the suction valve. these are situations that can cause it. Again, temperatures. You got to measure those temperatures.
Yep.
And see what's happening. If the compressor seems to be running too hot, you got really high discharge temperatures, you're looking at overloads.
Yep.
So
exactly.
Did the overload protection device quit?
Mm.
You know, a lot of guys in our particular case, we have overload protection on our modules that have a little jumper on them. And that little jumper prevents that module from automatically resetting. And we get into the field, and a lot of times we see the jumpers missing. When the jumper is missing on our overload, that thing is resetting every time. So you have an overload condition, it's overheated, it's got an electrical overload, caused those thermistors in the motor windings to send the resistance above 4.7 kiloohms. The module says, shut her down. And it drops below 2.3 kiloohms, which is the lower reset point. And the module says, okay, we're all good. The windings are good. Start it up again. You haven't addressed what caused that motor overload. All you're doing is killing the compressor. You're allowing it to run in a situation that needs to be diagnosed and fixed before it's allowed to run again.
Exactly. Because this is the funniest thing too, is like, I've talked to so many technicians, even I did it in the field. You know, you get that oil failure control and it tripped off in the middle of the night. You go in and you reset it. Oh, it's working. It's running fine. I sat and watched it for 20 minutes. Oh, and it's totally fine. There's no such thing as nuisance trip. Something caused that to trip electrically or mechanically, but there is an issue just like that. If that tripped off, your motor overload open, something caused it to open. It wasn't just, it just happened once. It's not going to happen again.
Absolutely. Absolutely. We need to get into that. You need to see, okay, it's running. Get out the gauges, get out your temperature sensors, get everything on there and say, what happened? You know, what's the oil level in the compressor? Why did this trip? What's going on here? Check that oil pressure. If it's a pump compressor, check that oil pressure.
Yeah. And sometimes you do have to sit on a bucket and watch it. I've done it before. You know, you just got to sit there and wait. It doesn't happen that instance.
Patience.
Yeah.
Patience is key. Patience is key.
It could be a certain compressor turns on. It could be a certain system goes in hot gas defrost. It could be a certain thing that comes out of defrost. It could be one of many things. And sometimes you just got to take the time and sit there. And that's part of our job.
Right. Right. Some of the other things we've seen, this kind of a failure when I'm looking inside and I see a slot burn like this. This means that something has got in there, some kind of contamination, or as it says here, or you've got a voltage surge. Voltage surges, we don't see a lot of those failures. Now, are they coming back on inspection compressors? When we do inspections, they're mainly for warranty claims or a customer requests, you know, can you do an inspection on this? Tell me what happened so I can fix the problem. We'll do those. We do get a lot of salvage core returns that we don't inspect those unless we're specifically asked. So I don't know if, you know, I can't tell you if we've got voltage surges, more voltage surges in there. But on the ones we do inspect, no, we don't see surges a lot. What we do see is a lot of contaminants.
Yeah.
It's crazy.
That's us as technicians doing it. You know, we can't blame anyone else because the manufacturers aren't sending out the compressors with full of dirt and, you know, copper shavings inside them and stuff like that, right? That's what we're doing and when we're installing a system.
Absolutely. Let me show you a great example right here. This is a sulfos rod that we found in the motor cover of a compressor that we inspected.
Wow. Yeah.
That's a 6-inch length of welding rod. Yeah.
And it made it through the screens and made it through the some part of the system in the suction line, I'm assuming, to get in there.
We see many come back. There's no screen in the suction. The screen that we put in the factory and everything is no longer in place.
Yeah. And this is why you need to understand every component inside that compressor you're working on. Go and look at all. Bitzer has all this information out there. Go and take a look. Investigate on that specific compressor because their 2-cylinder compressor is going to be different than their 6-cylinder compressor or their 8-cylinder compressor. So you got to understand each one. So this takes time. You don't learn all of this overnight.
No. 20 years it takes.
20 years. I know. But you can fast track by going in and inspecting more instead of just pulling one out, putting one in, and going to the next job. Do that inspection, and over time you'll learn more and more. Man, Dean, I love this conversation. We're gonna have to do this again because I know there's so much more that we can talk about that I'd love to dive in with you. What would be a couple final thoughts for some technicians out there, how that they could start fast tracking their knowledge, really bringing more value to their customers, bringing more value to their businesses? A couple tips for them.
Go talk with your wholesalers, or talk with a Bitzer representative or a Copeland representative, whoever you want to work on. Get them to give you the training. Find out where their trainings are. Go and attend these trainings. Believe me, they're fantastic. The guys that do these trainings have been doing this for a long, long time. They're going to open your eyes to a lot of situations that you may not be aware of. So educate yourself. Go see Trevor. Go on, take his training programs. Learn about this stuff. Give us a call. If you have a situation, you're questioning something, we offer services to help out with that. Site services occasionally, if it's warranted. You got a supermarket where you've lost 6 compressors on there. Well, we need to go in and help you find out what's going on. Give us a call. Don't be afraid to learn about these things. Take one of those old compressors home if you're inclined to. You like mystery novels and clue novels and detective stories. Take the thing apart. Let's go. Don't be afraid of it. Even if you're just thinking about replacing the compressor, look at it first. Open the heads. Do what you need to do. Open things up. Look at them. Say, do I need to replace the compressor? Can I get away with a valve plate and a gasket? Is everything else solid?
Yeah, I love that.
And guys, change your contactors when you change the compressor.
Every time.
Don't even question it. Just, if you're changing the compressor, go get a properly sized contactor. Change that contactor. It'll save you tons of grief.
Yeah, I totally agree with that. And I like what you said that. And this is not only one training. Like you go to a Bitzer training, 2 years down the road, go to another one, or go to Absolutely. Another. Just don't. You got to consistently do this, because you're going to learn something different from somebody else who is teaching it. And even if it's the same person teaching it, you're going to learn something. These are more questions you can have. You have 2 more years of experience, maybe different things you see, and getting into these training sessions like the manufacturers have, like I have, that you can dive into this stuff. And this is what we talk about all the time. We want you to get to your next level. We don't want the customers to have to pay more out of their pocket because you didn't inspect it. And it just takes time, and inspect those compressors and take a look at them. Dean, how can people get a hold of you, your organization, if they want to learn more, if they want to try to dive into some more knowledge from you guys?
Bitzer.ca. www.bitzer.ca are the Bitzer website. Get familiar with it. eParts, the selection software. Yeah. There's everything that you need is on that site. All the documentation is available on that site. You can get a hold of us here in Montreal, or you get a hold of us through your favorite wholesaler. Most of these guys, most of the wholesalers now in Canada are offering Bitzer hosted training sessions in their branches. If you hear of one, sign up, go. Like, we'd love to see you. Phil, Ron, Alex, and Kim, they'd love to see you. And we give trainings on all of this stuff. So give us a call, ask. We'll help direct you in the right way.
Yeah. Dean, thank you so much for sharing your knowledge with us. I know we're going to do this again because you're a wealth of knowledge of 20 years doing this. And like Dean said, you got to just continue to grow your knowledge, invest in yourself. The more you invest in yourself, the easier your job is going to be, because you're going to build your confidence. You're going to try a little more. You're going to try different things instead of doing the same thing day in, day out, pigeonholed right now. Because I know I talk to a lot of teachers. It's the same, so get in and take these trainings. Be like, let's try this. Let's size a contactor. Maybe you never sized a contactor before. We just talked about it. Go to your next system today. When you're driving to a system, go and check the nameplate of that compressor, and then go size it yourself and check, is that the right size? This is how you learn, going out in the field and doing the stuff we're talking about. Dean, thank you so much for taking the time to come on the Refrigeration Mentor podcast, and we'll see you at the next one.
Thank you very much, Trevor. Thanks, everybody. Have a great day.